The shuttle's sitting out on the launch pad during the nighttime as we're sleeping and getting ready, or some of us were sleeping. I guess the blue shift was up and about. They woke the red shift up about 5 hours before launch, which is fairly standard. We went in to have some breakfast, went to a weather briefing, and then immediately went in to get our suits on. Of course, in the suit room, we checked the suits for pressure integrity. There's Terry again, Tom, and he's the one in the orange suit. Steve and Dan and Jeff. And of course we take off from the crew quarters. It's a fairly standard scene, I guess. Jump on the Astrovan and head out to the pad where we get on board about 2.5 hours before launch. You'll see in just a second the water deluge is coming down, the engine's starting, and this time starting for good. A little twang, and again, when the solid rocket motors ignite, you're going out of town very quickly. It was a beautiful launch. It felt great on board. Jumped right up to 2.5 Gs, did our roll maneuver, throttled down, and had a very, I guess, nominal ascent. No failures of any sort. It was very nice.
Here's the ascent, and the expression we were kicked off the pad is an accurate one. Here's a pretty spectacular view of us penetrating a cloud layer. During our ascent, you can see the reflection off the clouds. And the dark line off to the left there is, of course, the shadow from our exhaust plume. Took us 8.5 minutes to get to space. Here come the solid rockets being kicked off the ET. If you watch carefully, you can see their exhaust tail off. And 8.5 minutes later, after liftoff, of course, we get rid of the ET tank and we're in space.
Next, we got the payload bay doors open, and Steve opened them up, and Dan took these pictures. You can see the port door going open, and it exposes the cargo bay in the Space Radar Lab to Earth for the first time. And the large slab-sided antenna is visible on the left. That's Sir C. XR is the tilted, folded segment up against its upper right corner, and the MAPS carbon monoxide pollution sensor is on the bridge structure at the forward end of the bay. Now inside, we were activating ourselves too. We got all our cameras out. We had 14 cameras to document the radar science on board and the MAPS pollution science. There's a large Linhof mapping camera, and I'm holding a Hasselblad telephoto lens. We took about 14,000 shots to document the science on board.
In addition to taking a lot of pictures, we changed out tapes on board which recorded the data. This radar puts out enough information. It's like 45 TV channels broadcasting at once, and by the end of the flight we had enough data that could have equivalent to floppy disks stacked up 15 miles high, so it was quite amount of data that we brought back. One of the recorders failed in flight, so we had to change it out. This is the failed recorder getting ready to be put back under the floor.
Now the radar needed to be pointed while we were up there in the right direction to all the sites on the ground. Here I am typing in one of the 400 plus maneuvers that it took. Each shift ended up doing about 11,000 keystrokes. This is a view that we didn't see too often. About every 24 hours we had to point the star trackers, which are located on the nose of the shuttle, towards the stars to align our inertial measurement units on board. And here we are coasting down, traveling southeast over India, the west coast of India.
Once we get the radar set up and ready to go, it's ready to start taking data. And the next scene that you're going to see is a picture of us passing over the Sahara Desert. As you can see that to the eye, it doesn't look very like there are many features, but when you turn the radar on, this is what the radar can see underneath the ground, or ancient riverbeds. And that was part of our study. This was a geological site that we wanted to understand the history of how the Sahara Desert became what it is today, because obviously its climate in the past must have been very different to have these riverbeds underneath.
Now, we were looking into Earth's past history here in the Sahara, but we also got a chance to see some of the dynamic geology going on Earth. On launch day, the Kluchevskoye volcano erupted up on Kamchatka, and you can see the ash and smoke plume going up over 50,000 feet here from this nadir view. You can even make out the lava flows going down the snow-covered sides of the volcano. And that ash plume was blown by the jet stream well out to the east, several hundred miles downstream. And the sight of this plume blowing downwind was really amazing each day when we came up over the horizon and saw this plume waiting for us over Kamchatka. And volcanoes were an important part of our studies on board. We were looking at 15 dangerous ones around the world that endanger populated areas. After a snowfall, Kluchevskoye was almost pristine again. You couldn't even tell that it had erupted. But in our radar data here, you can see in this false color image the ash colored in red on the mountain slopes, and the lime green lava flow that was freshly generated during our flight coming downslope towards the Kamchatka River Valley. And I had actually brought up a small volcanic rock on board to give a little talk about our volcanic studies, and we hoped by unraveling the past eruptive histories of these mountains to tell you about the future hazards of them.
Well, we worked 24 hours around the clock up there, and this is 2 out of the 3 people on the blue shift, with Tom on the left, myself on the right, and Steve Smith is the one out of that picture. Here we are coming over Australia. It was clear, although several fires, and we would point out these fires and indicate when there were fires so the MAPS instrument could correlate that to their measurements of carbon monoxide that they were making. Here we are coming over the Philippine Islands, and this is 3 times normal speed, so we really don't go that fast. And you can see the reflections off the water. We can actually see several hundred feet beneath the surface because of what these internal waves do to the surface of the water. You can't detect with the naked eye, but you can with the reflections.
And to continue the blue team's explanation of what we saw here, I welcomed you to the rooftop of the world. That's what this area is called. This is Tibet. Even the valleys in this area are 15 to 20,000 feet above sea level. This was one of the beautiful sights we saw. The blue team saw the Earth lit from Europe all the way through New Zealand. This was always one of our personal favorites, to see the beautiful iceberg-colored lakes up in the Tibetan highlands. And you see off in the distance there is the Himalayas, and past that is India. As Tom said, we took 14,000 pictures. It kept us very busy. It was often a competition to get to any certain window. This is Dan looking out the commander's window. We were rolled slightly so the commander's window looked at Earth. It was always nice to be able to pass the cameras so easily. We always had time for a little bit of fun as we prepared our meals here. This is the way our meals were packed. This is me bringing up the lunch tray here and showing Tom and Dan what they could have. We often ate on the fly for lunch very quickly. We did have more time for dinner. Before we went to sleep, we often went downstairs, which we call the middeck. That's Dan eating dinner on the ceiling, me on the left, and Tom doing a last-minute film change before we went to sleep.
Well, everybody knows that Mike Baker's so cool, calm, and collect, it's really hard to spin him up, so this is the only way I found on orbit to do it. Behind us there, you see the sleep bunks that we used. I couldn't quite get into it the same way that I learned as I was growing up, and it takes a while to practice to do it without banging your head too much. But it was nice to have those, and
Well, even though the shuttle was designed to be autonomous, you never can quite escape the ground. And nor would we want to. This is how we started every shift. We'd get a new attitude timeline, science timeline up from the ground, and changes to the flight plan. Like Dan said earlier, we had over 400 maneuvers we had to manually type in, and that equated to over 22,000 keystrokes. Every night pass, which was half our time up there, we would spend going over the flight plan, seeing what secondary activities we had to do, and also reviewing our onboard maps to study what land sites we were going to pass over. This upcoming scene, you'll be able to tell that this is a California pass because you can watch our commander get ready to take pictures of his home state.
You see it getting fairly excited here because we're getting ready to go over California. This is San Francisco Bay Area, San Jose. See the Sacramento area here, the Central Valley of California. Down here at the very bottom of the screen is Monterey Bay. And right in here somewhere is Fresno and Lemoore, where I'm from. At the top you can see the snow-capped Sierra Nevada mountains. And then pretty soon here you'll see this V is the San Andreas Fault and the Garlock Fault that come together right here. And right in there is Edwards Lake Bed. And then you'll be able to see Los Angeles and JPL, it's right in this area. San Diego right there. And at the top of the screen is the Salton Sea. And this light brown area you see in there is a large plankton bloom, a large agricultural area in the Colorado River Basin, and the Colorado River Delta that opens up into Baja. And of course on the bottom of the screen is the Baja California. And then you can see, as we look back over the pass that we just made, you can see Baja extending off into the north.
In addition to passes down California that were spectacular, this is the Chesapeake Bay area. You can see Baltimore up here, and Washington's just going off the screen there. Here's Potomac coming up to the Washington area. This area is very important because it acts as a nursery for fish, and one of our prime sites was to study the Gulf Stream just off of the shore of eastern Virginia. And as we pass down here, you can now see Norfolk, Virginia, my hometown, and Albemarle Sound, and down here is Cape Hatteras, and of course Kitty Hawk, where the Great Adventure started, is just down there. So this is a nice view looking south, going off the coast, and just off the coast here would be the Gulf Stream area, which we would study in sunglint with our cameras. This is a picture of South America looking north along the Andes. This particular area here is what we used as kind of our visual aid in helping locate where we were. Coquimbo, Chile is right in that bight along the coast. And as you cross over the Andes here, it almost looks very three-dimensional. There were a number of mountains and volcanoes that were of interest as geology sites.
In addition to our mission to Planet Earth primary payloads, we also had several experiments in the crew cabin. Here I am setting up a 100-pound chair, which is very easy to manipulate in space, for a head and eye movement experiment. Here Terry has a laser mounted to his head, and he and I both did this experiment where we moved the laser to follow a target that was on the forward bulkhead. And again, it was to judge how well our eyes were working with our head movements. And we actually saw some degradation during space. That's the target on the forward bulkhead. We also had to do daily maintenance to clean out filters. Anything that's loose flying within the shuttle actually ends up on these filters as they draw the air to them. That's the commercial protein crystal growth experiment, growing crystals of an anti-cancer drug. So we just use gray tape to clean all those filters every day.
Well, here I am caught again playing with my food. Actually, if you'll watch this, you'll see some pretty interesting fluid dynamics. Of course, what I'm trying to do is keep that tropical punch off my shirt. Success. Here's an exercise period, Bakes and Jeff. If you look carefully, you'll notice that Bakes is the only one with an ergometer. And here's Jeff with a model of the Starship Enterprise and also a model of the Shuttle. He took these up there because he knew that was the only thing Bakes and I were going to let him fly.
Here's Terry and I coming up to the flight deck to get ready to do one of the 14 trim burns that we did for the interferometry data takes towards the end of the mission. Dan put together a nice procedure along with the help of the phytos to get these burns trimmed down to an unprecedented accuracy of about 0.05 feet per second for the delta V goes. And we were able to successfully perform those burns and get the orbiter to within 200 feet of where it was the day before, and also within 200 feet of where the Endeavour was in April on the first flight of SRL. It's a pretty remarkable feat, I think. This is an example of what the acceleration of the Plus X jets will do to the folks on the middeck.
We put together the images from last April and October over Long Valley, California, an old volcanic crater in California, to make this three-dimensional topographic map, the whole objective of this interferometry experiment. And this is digital topography made from the radar without any contour elevations from the ground. Now, the radar was cooking throughout the whole 10 or 11 days of science, but eventually we started to run out of film. Here it is piling up, exposed in our storage bags on board. And when we ran down out of film, the radar was also running down its investigations. There's Mike and Jeff waving goodbye from the crew cabin. And while the sun was setting on SRL-2, we were also getting ourselves set up to come back for entry day, hopefully to Florida, but we wound up in California.
As you can see, we've turned our orbiting laboratory into a reentry vehicle and also an airplane. Jeff on the right there, there's a shot towards Bakes. You see out the window the glow of the atmosphere as we start to re-enter, and the hot plasma gases as they come over the orbiter periodically meet at overhead and cause bright flashes. There's looking over Terry's shoulder on the right-hand side, the pilot, and you see the sunset there, and there's Bakes flying.
At this point, you know, we take over manually at about 50,000 feet overhead the runway and fly it around the heading alignment cone. And here you see us turning on the final just prior to doing our subsonic DTO, or flight test, there's a little wing rock, which is about all the motion that you see out of the aileron doublet and yaw doublet that we did. We're coming down 18-degree glide path at 300 knots. At 2,000 feet, we performed the pre-flare to reduce our glide path to about 1.5 degrees. At 300 feet, Terry put the gear down. And we crossed the threshold at about 235 knots and 35 feet. Looking for a touchdown about 200. We touched down at 195, about 1 foot per second on the sync rate. And we were also doing the drag chute flight test, so we put the chute out immediately on main gear touchdown. Allowed it to fully deploy, and from touchdown to the start of derotation was about 15 knots. Started the derotation, got the nose on the ground about 130 knots, and started braking about 80 knots. And at 60 knots, you'll see in a second, we'll jettison the chute, and came to a stop about 12,000 feet down the runway with 3,000 feet remaining. It's a great flying machine. It was a joy to fly on this mission to planet Earth, and it was landing was a nice ending to a successful mission.
Great landing.
Thank you.